What we're going to talk about today, well, let's put it this way. Over the weekend, you guys are supposed to do a worksheet that was basically a way of you kind of getting a preliminary idea for your composite, this next project that we're going to do. And in the front, remember, it started asking questions like, what do you want your background to be? You know, what's the environment? What are some other elements you're going to have in this thing, and so on and so forth. And hopefully you realize that there needed to be basically, there has to be a background. There has to be 3 other foreground objects at least. And most successful composites, like the ones that I showed you guys on Friday, or was it Thursday? I think it was Thursday I showed you student work. Most of those were anywhere from a dozen to 50 or 60 layers to actually get the idea and make it happen. So what you have to do now is you now have to worry about how to find those images, right? I mean, that makes sense. That's our next problem. And this actually becomes a really, really, really big problem because of what is typical web resolution. Does anybody know how much how many pixels a high-def television has? When you go and buy a really nice TV, you're going to go buy the best TV is a 1080p, that's right. Okay, so what that means, okay, is that television has 1080 pixels vertically. The P we won't talk about, that doesn't matter. That's progressive scan versus interlaced and blah, blah, blah. We don't need to worry about that today. That's a big deal if you go to my video class, though. We'll talk about progressive scan versus interlaced and what that actually is. But here, 1080p, 1080 pixels tall, okay? Which to us, that's a lot, right? Now let me show you something. These monitors even, because these Macintosh monitors are incredibly good. If I go to my system preferences and I launch the displays panel here, you'll notice that on the iMac, now right now my resolution is set pretty low because I'm on the projector screen for you guys, plus I'm also capturing this for the web, so I'm not at the full resolution. But 2560 by 1440. Now that means that this monitor actually has about 400 more pixels vertically than even high def. So when you actually put a high definition signal, like a movie, if you download like a trailer from apples.com, the trailers section, everybody ever been to Apple's trailer website? It's really great because you can get these beautiful 1080p trailers that you can see that are nice and big. If you load one of these on this monitor at full resolution, it takes up just a little bit more than half of the screen, that's all. So these monitors are actually really high resolution. But they still are not the same resolution that we're going to need for our composites. Let me put it to you a different way here. If I'm, well, I've already done this for you, right? If I take this shape right now, as it is, and I scale it up, so if I go to Edit, Transform, Scale, and it's a lower resolution essentially. When I try and make it bigger, that's basically what it's going to look like. Does this make sense, right? We've already gone over this. The problem with getting your images off of the internet is that most of your images are really low resolution because the internet is what we call a screen resolution system. Now, in order to illustrate that fully for you, let me show you this, okay? When I go and make a new image, okay, let me just cancel this for a second. We were using an 8.5 by 11 at 300 pixels per inch, right? That's letter size. But when you're talking photography and stuff like that, really it's an 8 by 10 at 300 pixels per inch. Now, if I go to, I'm just going to go to Word and just type this out for you. If I have an 8-inch by 10-inch image, and that's at 300 pixels per inch, right? What are my dimensions going to be in pixels? total pixels. So what's 8 times 300? It's pretty simple math here, guys. What's 8 times 3? 24. You add the 2 zeros, 2400. Okay. And what's the width? 3000. Now, here's what I really want to show you. Actually, it'd be easier if I get my calculator out here. Okay. I know, math and art class, it's hard. But if I take 2400 and I multiply it by 3000, okay, 7,200,000 total pixels, okay, in that image, right? That's area. It should be basic geometry for you guys, right? Width times height. You guys have learned that since probably junior high school, I'm hoping, okay? So if I want to figure out, so right there. Now let's talk about cameras really quickly. You go to buy a digital camera. It's 14 million pixels, okay, 14 megapixels. Now we're going to learn a little bit more about that in the future, but a 14 megapixel camera is theoretically twice as many pixels as you need for a nice 8.5 by 11, which is good. However, I'll just tell you right now, we'll go more into this later, there's a reason why you can spend $3,000 on a really nice digital SLR that has only a 12 or a 14 megapixel chip in it, and you can go spend $200 on some camera that has an 18 megapixel chip. And that $3,000 chip that is less, or that is more money and less megapixels than the $200 one will have a better photograph. And there's a lot of reasons for that. But what I want you to just know right now, and we'll talk more about it in the future because I want to educate you guys in this kind of stuff too, is the whole megapixel thing. When they say, ooh, your cell phone camera's got 10 megapixels, it's not as good as a 10 megapixel camera, real camera. And it has to do with the physical size. They try and cram these things into this tiny little package, and the CCD is so small. Most CCDs are like a quarter of an inch or less. Let me say that again. Most CCDs are around a quarter of an inch, the cheap ones. An expensive CCD can be upwards of 1.5 inches long, but with the same megapixels. So there's a real big difference, and the big chips are much more expensive to produce and have a better image. So reality, megapixels means nothing when it comes to cameras. Well, not nothing, but it's not as important as they won't make you believe it is. But this here is telling us we need 7.2 million pixels in order to create a really good image. Now, just to kind of illustrate my point here, if we go back to the system preferences, my maximum resolution on the monitor is 2560 times 1440. So if I clear this and go 2560 times 1440, I get 3.6 million pixels. So if an image fills the screen on your Mac here, it's still not enough resolution for a print. And this is the key concept I want everybody to get right now. You cannot trust how big the image is on your screen when you go on the internet to look for a photograph for your composite. You can't do it. And the reason for that is because the monitor itself has less than half of the number of pixels that we need to make a good composite. I'll say that one more time. The monitor has, well, okay, it's a little bit more than half, but no, it's about right. It's almost exactly half of the number of pixels that we need to make a good image. And these monitors, guys, are like amazing, the best monitors. Most monitors that you have are 1080p. So 1080p, okay, is what is 1440 by 1080, okay? So a high definition TV is 1440 by 1080, I do believe. So if I go back to my calculator and I figure that out, because I can't do that math in my head, I wouldn't expect you to either, at least not for this class. So that's 1,555,200 pixels. So what I want you to see here is this. Even a high definition TV is about 1/6, 1/5 of the resolution that you need for a good, and an 8x10, guys, is not a big print. That's smaller than a sheet of paper. If you want an 11x17 or something really nice and big at 300 pixels per inch, which is what the industry standard is for a good print, you need a lot of pixels, guys. You need a lot of pixels. So if you want, let's say you're a graphics designer and you're making that movie poster, okay? And let's say it's a 20x30 inch poster. So just as a, so a movie poster is 20x30 inches at 300 pixels per inch. You now need, okay, well, we don't need to do that, right? You need 6,000 times 9,000 pixels, which gives you a total of, I don't trust my math, so I'm not going to embarrass myself here, 54 million pixels. So you need a 54 megapixel camera to do an image that size at its technically best optimal thing. Now you might sit there and go, I've never heard of a 50 megapixel camera. There is no such thing. Yes, there is. And you'd have to take out a second mortgage on your house to buy one because they're usually around $50,000 to $60,000. Actually, that's not true. They've come down. They're about 30 now, some of them. $30,000 for a lot of these. I used to sell them, some of the real big ones. And when I mean big, I mean literally 4 by 5 inches is the size of the sensor. Okay? And that's $40,000. And then on top of that, you got to slide that in a $10,000 camera. So it gets really pricey to do something like that. Really pricey. I used to sell them back in the early 90s when we thought even honestly, we thought a 20 megapixel camera was like amazing, and that cost 60 grand. So this is huge. This is the problem with a lot of modern graphics design, is the technical needs are much higher and very expensive than what a lot of people think. So here's your real problem. You've got all this, and the math is there. The math is really easy. It's width times height. That's all we're really worried about. But if you go to Google, and let's just say I want to search Google, and I want to type in mountains. Whoops. Okay, let's say I want a nice mountains background. Okay. That looks good. But when you roll over these, look at the resolution there. 415 by 322 pixels, 332 pixels. Well, that's not going to be big enough. Watch this. So I'm going to click on this, and I'm going to save the image to my desktop. So I'm going to put it on my desktop, the sawtooth. Minimize that for a second. We can get rid of this. No, don't save. Okay, Idaho Sawtooth Mountains, open with Photoshop. Now here's what I want you to see. Look at this, okay? That size doesn't really look all that different, does it? Well, let me close that. Okay, they're pretty close in size, right? No. Look at what this one says up here in a percentage. 25%. Whereas here, it says 100%. So if I take this picture, and I can tear this out like this, and then I take this layer, this is my 8x10 at 300 pixels per inch. I created this just a few minutes ago. If I take this layer here and drop it in there, look how big it is. And now, if I go and say, oh, that stinks, I need to make that bigger. Transform, scale, okay. Oh boy, that looks lovely. How about that? Yeah, all right. That's gonna get me a good grade. I'm being sarcastic. Yeah, just in case you didn't figure it out. All right. When you see images, and here's the biggest key. When you see things on the screen itself is a lower resolution than what you need. So a lot of pictures will look great on your monitor, but would not look good when you print them out. Let me say this again. A lot of images will look great on your monitor and will not look good when you print them out. I will say it a third time. There are a lot of images that will look great on your monitor, but will not look good when you print them out. Here's proof positive. So what you need to do when you go to Google, okay, is, let's get rid of this, and notice it smooths it out in Photoshop, and it kind of looks good, but if you zoom in on it, see, you can see it's just really nasty. It's not sharp at all, okay? Now look at what the percentage is here. This is 100%. I'm actually looking at this as real size right now. Real size pixel by pixel, not real size physically 8 by 10. Okay? When it says 50%, what that means is there are 2 pixels in this image covered by each pixel of the monitor. If I go to 100%, whoops, one more, then that means there's 1 pixel in this image for 1 pixel on the monitor. Does that make sense to you guys maybe? That's a hard thing to think about. So if I go to 25% here, which is where I can actually see the whole image, that means there's 4 pixels here for every 1 pixel on my monitor. So I'm really not seeing the quality. That's how Photoshop tells you that. So let's trash this layer here. Well, no, let's keep this layer and let's see if we can find a better picture, actually. So I'm going to go back to Google, and then here's this little trick. Click back here and back again. Down along the left here, you can choose your size. So you could, now see, that's not a bad one. That's 2048 by 1536, but that's still about only half of what we need. We need 3000 by 2400. So what I'm going to do is go over here to any size, and then you can click larger than. And now I can select the size and see how it has the megapixels here. Well, then I'm going to select 8 megapixels. That'll give me whatever I need that's bigger than. So if I can go and find a nice image in here of mountains that I like, that one's pretty cool. Yeah, let's click that one. I want to show you the difference in sharpness now. So I'm going to click this, click the full-sized image. It's going. There we go. Right-click, save image as, put it on my desktop just for easy access. You guys should be putting them in your media students folder. In fact, what I recommend right now, so I'm going to let you guys go back. You're going to start doing searches for what you need, okay? Make a new folder in your media students folder called composite. Then inside that, make another folder that says found images or internet images and just start saving. And here's the thing. So I want a background of mountains. I would probably save 4, 5, 6, 7, 10 of these. Because sometimes, you guys know the internet changes like every 2 hours. It's building and going every 20 minutes. You could do a search again tomorrow for mountains, and this photograph could be gone. Because the person decided to delete it off the internet, right? That happens all the time. So if you want something and you see it, save it. Because it might not be there tomorrow. So that's another really key thing. So I'm going to save it. Let's minimize this. Go back in here. Where is it? There we go. Open with Photoshop. Well, gee, it looks the same size as this one. It's exactly the same size. No, it's so much bigger. So I'll just tear this out here and drag the layer right in there. Now, here's what I'm going to do. I'm going to take this to 100%. So 25, 33%, 50%, 60, 100%. There's 100%. Now look at this. I'm going to turn this layer off. That's what it looks like. That's what this one looks like. Can you see how horrible that is? Look at the difference in quality of sharpness of the image. Do you see that? This is blurry because when I scaled it up, Photoshop did its best job of trying to, what we call, res up the image. But how does it do that? All it can do is look at the pixels next to the pixel that it already has and just create a bunch more. That's all it does. It's a process that we call interpolation. And interpolation is another really big issue in digital cameras and scanners and all sorts of stuff. There's a lot of scanners, especially like flatbed scanners, printers that you guys buy, right? It'll say 3,600 pixels per inch, and then in fine print it says interpolated. And then it'll say optical resolution is only 2,400 pixels per inch. And what that means is that the software just starts duplicating pixels. And they can advertise it that way, and if you don't know what they're talking about, the interpolation process, if you don't know what that means, you go spend extra money on a scanner and think it's really good when it's not. It's just copying pixels to make it seem better. And it's not really a great scanner. So this is this whole issue of resolution and software interpolation and megapixels is actually a really huge issue for you guys, because as you guys start to buy digital items like cameras, scanners, cell phones, whatever, it's really important to understand and be informed what really makes a difference in the quality of an image. If you want a really good camera, or you want a cell phone that has a really good CCD in it, or a real good camera in it, you got to start knowing a lot of, some of this stuff. The real big thing about the new iPhone, right, was it has this new camera, and it's 8 megapixels and all that sort of stuff, and I went, okay, 8 megapixels, no big deal. But the real big thing about the iPhone S, the 4S, is it has what they call backside illuminated sensor. Go Google that. That is why the new iPhone camera is going to be so amazing. It is. The pictures that are going to come off that thing are going to be so much prettier than almost any other cell phone out there. And I've heard students say to me, oh, it doesn't matter, there's Droid phones with 10 megapixel cameras or whatever out there now, so I don't care. Take the 10 megapixel camera, you can have it. I want a camera that has a backside illuminated chip because it's so much better. So this kind of stuff is going to be important for you, because there's a lot, the manufacturers count on the fact that you guys don't know what you're talking about when it comes to cameras, and you'll go spend extra money on a camera with more resolution when you don't need it. So a lot of people just don't even understand how it works. So you can see it here. You can see the effect here that the resolution has. You can scale something up, but look at the quality difference. That's what's really huge. So when you go to Google, you got to set that little slider on the left here, click, click, this right here, to 8 megapixels. Now, let me say something though. That's only if the image that you're going to have has to fill the whole page. If it's going to be a little tiny bird that's way off in the back corner of the background and it's only going to be like half an inch big, then you don't need this full resolution. And then you might say, well, what kind of resolution do I need? Well, do the math. If you're gonna have a photograph of an eagle flying in the background of this shot, let's say these mountains, and it's going to be roughly about 2 inches big, roughly, okay? So if I go in here and I search for an eagle, okay, well, 2 inches times 300 pixels per inch is what? How many pixels on the longest side? 600, thank you. 2 times 3, very good. Okay, so really, here I am looking at images that are 8 megapixels big when I don't need that. So I can go down here to about here, say 1024 by 768. I like to go one step up just so that I have a better version. And, if I'm having it flying, other important considerations, don't have it cropped. See how the wing is going out of the picture here? Well, that might look a little weird, right? If I put that in the image and the wing just stops, but he's in the middle of my picture, that's going to look kind of stupid, right? So I want one where I can see the whole thing. I might, you know, what's the difference between this shot and this shot? Well, here looks like he's landing or about to grab something. See, like this. But this one, he's flying, he's still soaring, so this would probably be a better image. Or do I like this one where he's got his mouth open and you see it's a little more aggressive? So you got to really sort through your images. It's going to be a lot of looking. You're going to spend days just looking for pictures. And sometimes it's going to be really hard to find. So if I click in here, and if you're not sure about an image, here's what you do. Oh, I hate it when that disappears. What? Hopefully I just clicked on the right link. Ah. There we go. Got it fast enough. So if I save the image again, okay, save it, minimize this, close that, and I go and I open up the Eagle. Here's your true test. When you open it in Photoshop and you tear it up and you just drop it in your photograph, you can just do it like this, drop the layer in, boom. If he is bigger than or equal to the size you need him, then your resolution is fine. If it comes in and it's too small, don't scale up. Find another picture. It's just that simple. So if you're not quite sure of the math, well then just go ahead and try it. And if it comes into Photoshop too small, don't scale it up. Just delete the layer and go find another picture. Does that make sense? So that's actually the easiest part of the whole deal. If you're not sure about it, copy and paste them into Photoshop, see what happens. Okay? Make sense? The other thing is I want you to be saving all these pictures. Don't just drag them into the Photoshop image from Safari. That will work. But don't do that because I want you to keep them. If your Macintosh crashes or Photoshop crashes while you're building your image and you didn't save it, you don't have to go searching through Google again. You have all your images saved into a folder. Does that make sense too? Okay, so that you have the backups. There was one other thing. Oh, yes, the other thing people will do when they're searching, and this is a really big problem, is people will save this picture. This is a low resolution thumbnail. You have to go and click the, I don't know where it went, that's really frustrating. Okay, you have to go and click on the full-sized image right there and then let it load. Boy, that's a big one. Okay, and let it load. If you just save this one here, I don't think that's the full resolution version. And especially some people will even do this. They'll right click on this and say save image as. No, 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 no. That's a tiny little thumbnail. And so they get all confused when they bring it into Photoshop and it's really small. I don't understand. It says it was 6,000 pixels, but it's really tiny. Well, it's because you didn't save the real image, guys. You saved the thumbnail. You got to go in here and then click full-sized image and let it load. And if it's a real big image like this one, it may take a minute or two, even on our nice internet connection. Does that make sense to everybody? Okay, so what I need you to do